this is question number 5 in section 2.1, the tangent and velocity problem in Stewart's 7th edition calculus book. I would recommend seeing the previous videos for this section if this one is a little hard to follow. So question 5 says, if a ball is thrown into the air with a velocity of 40 feet per second, its height in feet per second later is given by the equation y equals 40t minus 16t squared. Part A is asking you to find the average velocity for the time period beginning at 2 seconds and lasting 0.5 seconds, 0.1 second, 0.05 seconds, and 0.01 seconds. Part B says estimate the instantaneous velocity when t equals 2. So, part 1, you're given this 0.5 seconds, and basically, you're beginning at this t equals 2 here, and so you're gonna have, you can set this little 0.5 parameter equal to h, or you could just say like 2 plus h is 2.5. You just add it to 2, or you could set it equal to h and then have your setup as y of 2 plus h minus y of 2 over 2 plus h minus 2, which is like previous problems where you just have like y2 minus y1 over x2 minus x1, and this meaning you're plugging this 2.5 here into the function up here for y, and you're plugging in the 2 for this function of y also, and then that'll give you your y coordinates for the numerator, and in the denominator you will just have your x coordinates, which will be 2.5 and 2. So working that out, you'll have this equation. You plug in 2.5 to it, 40 times t minus 16 times t squared. 40 times 2.5 minus 16 times 2.5 squared. This quantity minus 40 times 2 minus 16 times 2 squared over 2.5 minus 2. And working that out, you get negative 32 feet per second. Now part 2 is asking for 0.1 seconds. You go about it the same method, starting at 2 seconds and lasting 0.1 seconds. Then you would have your h equal to 0.1, so your y of 2 would be y of 2.1, and your y of 1 would be y of 2 over 2.1 minus 2. And working that all out here, again, you can see the y of 2 is the same from part A, because you're just plugging 2 into this equation here. And you're plugging 2.1 into the same equation, plugging in 2.1 for t, and over 2.1 minus 2. And it comes out to negative 25.6 feet per second. Now, part 3 is starting at 2, lasting 0.05 seconds. So, same method. Since we already worked out that y of 2 is equal to 16, I started just substituting in 16 for the function at 2 seconds. But you can see y of 2.05 is plugged into the equation, minus y of 2 and over 2.05 minus 2, and you get negative 24.8 feet per second. Part 4 is lasting 0.01 seconds, starting at 2. Same method. You'll be plugging 2.01 into the equation for t, subtracting your y of 2, your equation at t equals 2, over 2.01 minus 2, and you get 24.16 feet per second. Now, part B was asking to estimate the instantaneous velocity when t equals 2. So, when t equals 2, h is approaching 0. So, if you pick an h sufficiently small that it is basically like really close to the function at 2, I chose 0.0001. And using the same method, plugging in this sufficiently small h value and working it out, you get this number, which is similar to your last couple numbers, which are also pretty small and pretty small h values, close to 2. And those gave you negative 24.8, negative 24.16. So plugging in an even smaller h value is even more accurate, which gives you negative 24.0016 feet per second. So at t equals 2, we can say the instantaneous velocity is about negative 24 feet per second. Since you can see, it seems that the slope of the tangent line is approaching negative 24 feet per second.